We got 2 weeks left in the 9 weeks from what I've looked at. So we're gonna hit chapter 9. We'll probably hit, there's one last quiz/test. I'm not sure how many points it's worth, probably next week. But take a look where your grade is. Okay, take a look where your grade is at some point. Just kind of heading into the last 2 weeks. You know, if you're really borderline, you know, one grade or another, you know, this is an opportunity to get it up to the higher one if you would. All right, we're starting in chapter 9. Quadratic functions. What do you remember about quadratics? What's that word? Does that word ring any bells?
No. It's something with 4.
Not 4. No, not 4. Jordan?
2.
Something with a 2. Can we give me an example maybe of a quadratic equation?
2 promise.
An equation with 2.
Just the number 2?
No, like 2 sides of an equation.
No.
This is bad news.
All right, yeah, we're a little off. We'll get there though. We'll get there.
That's all, Josh.
The exponent needs to be a 2. Something squared. Something squared is quadratic. Okay, so that is where the 2 comes from. Now this is that kind of that first statement you got there. The function y equals x squared is this graph here. All right. This function is a quadratic function. A quadratic function is any function that can be written in the form y equals ax squared plus bx plus c, where a, b, and c are real numbers. So what that means is so you can have y equals 3x squared plus 7x plus 2. It's quadratic. Y equals negative 4x squared minus 3x plus 7 is quadratic. Now, you don't have to have all 3 terms, but you do have to have the x squared term. So it could just be y equals 2x squared plus 7. It could be y equals 3x squared minus 5x. But you got to have the x squared. Or it could just be y equals x squared. All of those are quadratic because they have a squared in it. Okay. This is, and you've done this several times, you've graphed y equals x squared. What do we call that graph? It has a little special name. It starts with a P and it rhymes with arabola.
Terrible.
Arabola.
Parabola.
Parabola.
Thank you.
There you go.
This is last. This last one. His brain's burned out.
That's what I said. That's what I meant.
Well, we don't call it bola. Parabola. All right. We're going to go over different ways to identify functions. If you're given this, it's a little bit easier, okay, but you're not always going to be given this. One of the things they talk about here, a constant change in x. In linear, we talked about a constant change in x gives you a constant change in y. We did the differences. Well, those are the first differences. For a quadratic, okay, this is our y equals x squared. When we plug in 0, you get back 0. 1 squared is 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. All right, do you see where that table is on your sheet? Okay, what you want to do is we want to figure out the first differences. You want to take 1 minus 0, which is 1. 4 minus 1 is 3. 9 minus 4 is 5. 16 minus 9 is 7. Put that right underneath that chart. Okay, that first little area there. So we're going to take the differences. You always go right to left when you subtract. And you can also just think about, all right, how do I get to the next number? I go up 1, I go up 3, I go up 5, I go up 7. Those are your first differences. What are our second differences, though? To go from 1 to 3, I go up 2. To go up from 3 to 5, I go up 2. To go up from 5 to 7, I go up 2. Those are all the same. That is going to be the case for a quadratic. Go ahead and get down the second differences. Right underneath them. Yeah, don't need to erase anything. So the second differences are all the same. That is going to be true for a quadratic function. Okay. They will have a constant second difference. Now, the only thing you got to watch is you got to make sure the initial x goes up equally. Like you can't go from 0 to 1 to 8 to 12. It's got to go up the same amount every time. Either up by 1 or up by 2s for the x's, and then the second differences are going to be the same. And this is what that caution says. Make sure there's a constant change in the x values before you find the first or second differences. All right, how do we do this? I don't know the equation, and I'm testing it to see whether it's quadratic. You've got to test the second difference. What we can do is we start right here, and we're going to figure out, so -9 to -2. You either subtract the second minus the first, or you can just figure out, all right, how do I get from -9 to -2? Do you add or do you subtract? Do you go up, Colin?
Add 7.
Add 7, so that would be +7. So put a little +7 there. And so we're going to do this right to the right. Everyone put that down. Yep, right on that chart. -2 to -1. Sam, how do I get from -2 to -1?
Is it +1?
+1. How do I get from -1 to 0? Okay, that's also what?
+1.
+1. And then 0 to 7 is +7. Make sure that makes sense. Those are your first differences. They're not a constant. If they were a constant, it'd be linear. Now we got to test it to see whether it's quadratic by testing the second differences. Okay, that'll tell us whether it's quadratic. You can also start at the bottom, go 7 minus 0, 7. 0 minus -1, 1. That'll work as well. All right, 7 to 1. How do I get there? Okay, what am I doing to get there? Let's see if this is making sense. Jordan?
-6.
Good, -6. 1 to 1. That is a 0. You didn't go anywhere. And 1 to 7 is a +6. Those are not the same. What does that tell you about the function? Is it quadratic?
No.
No. So you would say not quadratic. You can put that underneath it or where you have room. Not quadratic. You're testing the second differences, so it's not going to look like a parabola. All right, here's your other, or that next chart for B. Got to do this, and you got to show me the first difference and second differences. So we got 4 to 1, 1 to 0, 0 to 1, and 1 to 4. All right, so 4 to 1, Zach, what would be, how do I get there?
-3.
-3, good. Christian, from 1 to 0.
-1.
-1. Hanan, how about 0 to 1? +1. Jay Lee, how about 1 to 4? +3. All right, so they're not the same. Now we test the second differences. Really be careful here. Colin?
+2.
-3 to -1 is +2. -3 to -1 is +2. -1 to 1, Christian? +2, and then 1 to 3, I can do that one. +2. All the same, right? What's that mean, Preston? It is quadratic. So this is quadratic. Okay, your second differences are constant. Now, what if I just give you the equation? So you take a look at C there. You need to just look at that. Go ahead and get this for sure. All right, is that quadratic? Connor, what's your gut tell you?
It is not.
It is not quadratic. Why? What's it missing?
It's missing the x squared.
It's missing the x squared. Doesn't have an x squared, not quadratic. So good. So really, you should be able to tell me it's not quadratic just by looking at it. And D, y minus 10x squared is that one is going to be
Quadratic.
quadratic. And the only thing you've got to watch is if something adds or subtracts is 0, and cancels out that x squared. So that'll be quadratic.
Do you have a list of who did the bonus stuff?
I already got it.
Ooh, those ones out.
Yeah, who you know? I got it. Sounding like it's
Give me two. All right, stack them up.
Didn't you have to do both? You got that A on the test, now you gotta work hard.
right. Okay. Hey, and that little helpful hint there at the bottom, that's just like what we talked about earlier. As long as you have an x squared, you're okay. As long as you have an x squared, it's quadratic. All right, flip it over in the back. Okay. We said the graph of a function. You need something?
I'm so sorry.
We said that the graph is a parabola, and it's going to be a U shape. If you see an x squared, you got to think U shaped in the end. Now it says use a table of values to graph the quadratic function. So you got y equals x squared plus 2 there. All right, so right below the equation, make a little xy chart. It doesn't tell us what you plug in. So technically you can plug in anything you want, but that doesn't, that's not always the best option.
Isn't it -2, -1, 0, 1, and 2?
Yeah, I would start with, for now, always start with -2, -1, 0, 1, and 2. Now, last time we did this, we were still getting some mistakes. You got to remember, when you're plugging in -2 and you're squaring it, you have got to put the -2 in parentheses when you're squaring it, because that's going to be 4 plus 2, which is 6. That answer should be 6. If you don't put it in parentheses, it's going to tell you it's -2, which is incorrect. So make sure you put it in parentheses. Okay, anytime you're substituting a negative into that x squared piece. All right, so plug in 1, plug in 0, plug in -1, plug in 0, plug in 1, and plug in 2. Okay, before that. And so when we do that, Evan, what'd you get when you plugged in -1?
3.
You got 3, good. When you plug in 0, you should get 2. When we plug in 1, what do we get back? 3. And then when we plug in 2, what do we get back? 6. If you plot the points and they don't look like a U, that means you probably either didn't plot enough points or you didn't put the negative in parentheses. So -2, 6, put a dot there. -1, 3, 0, 2, 1, 3, 2, 6. Now up here, it says connect the points with a smooth curve. Go past your first point and your last point just a little bit. Make sure you put arrows on the graph because it doesn't just stop there. It keeps going all infinitely up. Yep, I'm just connecting. So it should look like a little bit of a U. Okay, actually connect them. Put arrows on it. All right, so for that second one, all right, again, you got to be careful. We are going to use -2, -1, 0, 1, and 2. All right, plug in -2, and let me know what do you get? Push down. What was that? How do you what? It doesn't tell you what we're always gonna do when we do -2, -1. What's that? Okay. How do you get that? Two squares. This is what you plug in. Wait. You put it right there. I think that's what you want to play. You're gonna plug in negative.
Yeah.
I thought.
You're gonna plug in negative. So.
Yeah.
And what do you get?
One behind.
Squared.
It just.
-1, -2, 1, -2, -11.
Should be -11.
Connor, what'd you get when you plugged in -2?
How do you calculate?
What'd you get?
I didn't get anything.
You didn't get anything.
No, I'm trying to figure out how do you.
All right, I'll show you here in a second. Okay, what do you got, Jordan?
I got 13.
Oh, you got 13?
Yeah.
It's wrong. Then you're all wrong. Josh.
I got 5.
Oh, you're wrong.
I got 6.
Oh, how'd you get 5, Colin?
-11.
-11. Okay.
You're not funny.
All right, Connor said, how do I plug this in? Hey, listen. First of all, you need to be able to operate without the calculator as well, because if you plug it in wrong, don't assume it's correct. So I'm gonna do this, and then I'm gonna plug it into the calculator. You gotta follow the rules. You got a -3. What are we letting x equal? X is -2. Okay, -2 squared. You have to follow order of operations. What's -2 times -2? It is +4. Now, -3 times 4 is -12, and -12 plus 1, -11. So that's where we get that. Here on your calculator, if you type it in just like it looks with using parentheses around the x, it will give you the same thing. Okay? But you should also kind of have a mental check in the back of your mind. So, all right, what do I get when I plug in -2? You should be able to go through that work, see if it matches up. So I got -11. Okay. All right, -1. What do we get when we plug in that? Okay, Evan?
-2.
He says -2. That will be correct. Okay, 0. How about 0? Okay, Colin. 1. Okay, now if you haven't already done so, plug in 1 and plug in 2 and see what you get. Because your calculator is absolutely fine. And don't plot the points yet. If you haven't plotted the points, just wait. If you haven't plotted the points, just wait. But if you haven't, it's okay. All right, Josh, what do you get when you plug in 1 and plug in 2?
I got 11.
+2 or -2?
Positive.
How are you getting positive?
I don't know.
You're both negative.
All right, 'cause we gotta be, that's the problem. All right.
I'm not
Colin, just type this into the calculator and then put parentheses right here. And then put in the number. It's not that hard.
I don't know what it was.
Just put the number in the parentheses.
Okay.
Yeah, there you go.
Should get -2 and -11. Now, I said to wait if you haven't graphed it yet because I'm going to spread it out a little bit. Where this 4 is, I'm just going to make that a 1, and where that 8 is, I'm going to make that a 2, just to make it a little bit wider. I'm going to make that -1, and we'll make that -2. Okay, I'll keep the y values the same. So -2, -11. Well, -11 would just be a little bit off of there. So that'll be down there. -1, -2 will be right here. 0, 1, 1, -2, 2, -11. Connect it with a smooth curve. So it looks like that.
If you get it wrong, I'm not surprised. So, probably the problem, the inspector.
Okay. Yeah, if you left, that's fine. I just switched mine. I just made it a little bit wider. You can leave. If you had already graphed it, yours is going to be thinner. That's fine. That's fine. What don't you get, Josh?
You got like 1.5, that's like one of your decimal points.
Where at?
Where?
You see like the wide.
Here?
The y goes up by 1.
No.
The x goes up
The other
by.
one, down all the way, yeah, right there.
Here?
That's 11.
It's like 1.5, or like 1.7.
Well, that's negative. That's,
Oh, is that on the 2?
yeah. Yeah, right there. Okay.
It's a 5K.
All right. One of the big issues here is I want you to see one of them opens up, one of them opens down. And there's something, hey, listen up. We need to be able to figure out when it opens up and when it opens down. And that has to do with the equation. If you take a look at those two statements there below, okay, the value of A, and A is the number in front of x squared, determines when it opens up or down. So parabola opens upward when A is greater than 0, positive. Parabola opens down when A is less than 0. Only when y is by itself, which these equations work. So if this is just a positive x squared, it's going to open up automatically. That's a negative x squared, it's going to open down. Okay, so we should know that ahead of time before we graph it. And if it doesn't like open up or open down according to what it should, we've got to double check our points. But right there, that's what's going to tell us whether it opens up or opens down, is whether that is positive or negative. Now, if you take a look at those examples, you don't need to graph it. I just want to know whether it opens up or opens down. Okay, as you take a look at that first one, A there, Preston, would you say opens up or opens down?
Opens down.
Opens down, and he's right. One thing you got to watch, though, make sure you identify where the x squared is, and probably rearrange them. Don't go by whatever the first term is. It's whatever the x squared is. So we should rewrite this as negative 3x squared plus 5x. Since that x squared part is negative, it's going to open down. So put that down for A, opens down. Now also, you cannot look at this one and give me the answer. You cannot give me the answer till you move it. That is up. It is going to open up. But you can't say, well, it is a negative. You can't say up or down until you get y by itself. Okay, till that is by itself. Which means for this one here, I got to move this to the other side. Now remember, you can't combine terms that don't have the same exponent. So the only thing I can do here is write this as y equals 1/3 x squared plus x minus 3. And this opens upward. Okay, opens upward. So just be careful those two. First one here. Watch what order they're in. You're always just looking at the x squared, once y by itself. Second one here, you got to make sure y is isolated. Third one, y and f of x serve the same purpose. Just tells you we have a function. You can just leave it just like it is. As long as the f of x is alone, you can look at that And so Joe, how would this open?
Or down.
You're right, it's up or down. It's gotta be one of those. Christiana, okay, what's making you pick up? Because you both said that.
Because, two negatives. and then-
The two negatives?
I just knew two negatives and I thought it was positive.
Okay, and here's the case. Well, all you gotta do is look at that and nothing else. Is it negative? Yep, that means it opens down. Don't think like a negative times a negative, anything else. And really, nothing else matters. It's whatever that x squared term is. If that x squared term is negative, opens down. If that x squared term is positive, opens up. Which, we said, when you graph it, make sure you understand, opens up. Okay, would look like this, opens down, look like this. It's gotta match with what you set according to the equation. All right, we talk about, it's gonna have a minimum, it's gonna have a maximum, or a maximum based upon the vertex. The vertex is the point where it changes direction. So we can identify the vertex as a point, and we could say that's the lowest value would be 0. This right here is the vertex, 3, 5. That means the maximum value is 5. So that's that point right there on that bottom part of that page. So find the vertex, be able to tell me whether it's a minimum or a maximum. So go ahead and flip it over. The vertex is a point. The minimum or maximum is just a number. Sam, what would be the vertex for part A there?
Is it 4, 3, or 4, 2?
The point 4, 2
Oh, I meant negative 4.
is right there.
I meant negative 4. 2.
Okay, that sounds a lot better. Vertex, negative 3?
Yeah.
Well, at least that's better, not perfect. Negative 3, 2. All right, now, is that the highest point or the lowest point? Lowest point, so that's the minimum. So the minimum is that 2. The minimum value is 2. It's going to be the y value. Minimum is 2. Okay. All right, now take a look at that one next to it. All right, don't make this too hard. Jordan?
2, 5. So, vertex.
Oh, hold on. What happened there? Okay, 2, 5. Vertex is 2, 5. Good. And Jordan, does it have a maximum or minimum?
Maximum.
And what would it be? 5. The highest point is 5. The highest spot on that. So the maximum equals 5. All right, now the thing we got to watch out next is what they call domain and range. Okay, for this one. In domain are your x values that you see, the range of your y values you see. So you take a look at that first one. They're kind of telling you, does that match up with that first one you got?
Yeah.
Okay. See this thing to the side? That shows you all the y values. Okay, it doesn't go below that line, does it? Okay. How would you describe this line? What numbers does it hit? Okay, I guess how would you describe what numbers it hits? Okay, any ideas?
1 all the way up to infinity.
1 all the way up to infinity. Okay, so do anything bigger than 1, right? So you're right. Now, the domain, so the range, that is your range. The easiest way to write that is y greater than or equal to 1. Okay. What about the x values? Does it have a point on the left that it stops or a point on the right that it stops? No, it's going to keep getting wider and wider and wider. So the range really goes both directions, right? How do we describe that? or excuse me, the domain. That's your domain. Goes both directions.
X is greater than or equal to 1.
Well, greater than or equal to 1 would mean it would start here and go to the right, but it wouldn't go anywhere to the left. Well, that means it would start there and go to the right, but doesn't it go to the left? It goes both directions, right? Zach?
X is less than or equal to 2, and then greater than or equal to X.
All right, and there's an easier way to write it. Is it gonna miss any numbers? No. How do we, if it's not gonna miss anything, what can we say? How do you say everything? All real numbers. So our domain is all real numbers because it hits everything. And you just said, it goes everywhere to the left, it goes everywhere to the right. The range doesn't. All right, let's get at least through one here.
That'd be all the time for what we're doing, right?
For quadratics, yes, it's going to be all the time. So don't make the domain too hard. So the domain, because you're going to go left and right, both directions, at any number you can plug in. So for that A there, the domain is all real numbers. That's the domain. All right, but what about the range? The range of the y values. I give you a clue, it's going to be either greater than or equal to or less than or equal to. And if it helps you out, like on the other one, you can say start where it is, draw an arrow. In this case, the arrow goes down. All right, Colin, what do you think for range?
Less than or equal to -3.
Y is less than or equal to -3. Yep, I agree with that. All the points below -3. Okay, all the points below -3. All right, so get that down. Okay, page 595. 22 through 44 even.
Evan. Look at that number.
Yeah.
20.
It's like 10.
Oh, it says even.
Even.
I was like, we talking about 22. I thought that. 24 is not 10.
Yeah.
Josh, you said we're at what?